8 or so with crystal sets and so on, and working my way through. And I always wanted to do radio communications. I don't know why, but I did. So I'll get to the first place that I worked at where did serious stuff was Commonwealth Electronics. They, oddly enough, were in an old house in Walkham Hills in the 1960s, early 1960s I started there. And it was just a converted house, so they had the factory, they had a machine shop, and it was funny because that morning tea time we can go and sit on the back step of this house and have our cup of tea and all that sort of stuff. And it was a regular place as well. I still remember I had because there were no female toilets, there were no females. Well, I might have been a secretary or two, but I know in the male toilet they had those round urinal things and ceramic things. And I thought it was hilariously funny. One of the sheet metal guys made some teeth and put it all around it. I can't remember if it was metal or cardboard, which I thought was hilarious as a young as a teenager. But he got fired over that, or supposedly. I got told nothing, so who knows? But it was a fantastic place. They only actually had one technician there, Noel Miller, VK2AXH. So I sort of knocked on the door and said, "Hey, I want a job." Oh, yeah, all right. And I could read very quickly, so I'd done a lot of reading, and I used to. My father would get me Radio and Hobbies magazine.
Radio, television, and hobby.
No.
Radio and hobbies.
Radio and Hobbies.
It was originally.
Yeah, originally Radio and Hobbies. Well, television wasn't even invented then.
Oh.
And
56 television.
And that was a really good magazine because they had how to do it articles, and often there'd be things like build your own noise and distortion meter or something like that. Now, I didn't have the money or that, but I read it and I sort of pretended to put it all together. But because they explained how it worked, when I first come across one of these, I could use it. I knew what it did. My whole approach has always been, I want to know how something works. If you know how it works, then you can figure out why it's not behaving, or what its limitations are, or how to fix it, those sorts of things. So I knew how all the gear worked, and so all these different instruments I've never seen before in real life, I could use them immediately. Never. Real men don't read handbooks anyway, but they didn't. In this place, didn't have handbooks, and that's so it's tremendous. The engineer in charge said, "Okay, Commonwealth Electronics made what you would call professional communications equipment for PMG, Department of Civil Aviation, and sometimes the military bought some of the stuff as well. And it was all done mostly to contracts. So PMG or Civil Aviation, PCA would issue a contract for blah 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 blah, and the company would tender for it and manufacture it, design it and manufacture it. And it was always, the requirements were always very tough. So they're always cutting edge sort of things that we were doing. So one of the things that Commonwealth Electronics had made in the past, remember this is early 90s, sort of the late 1950s, they made a little handheld VHF transceiver. The only transistors available were germanium transistors like OC 170s, 171, that sort of thing, that sort of, I can just sort of get there. And I forget how much output, it was probably 100 milliwatts, but they actually had a little handheld VHF transceiver, rechargeable NiCad battery and all that sort of stuff. And again, you couldn't buy NiCad batteries as a regular thing, so it was specially made for them. forget now, I think it was in the aircraft band. So for isolated airfields, like out in the country or whatever, this little radio was used for the person on the ground to guide the little aeroplane driving in, by communicating with them, the battery operated, all this sort of funny things like that. And they also made, because for outlying areas, a lot of telephone links were by radio. There wasn't over. It was duplex radio. So we made these single channel VHF links. And the previous generation, before I started there, was all valves. And so they were making a transistor one. And remember, the early 1960s transistors had only just been invented, so there wasn't a lot around. The valve one was everybody makes stuff in 19-inch wide racks. I don't know why 19-inch, but that's what it is. And so the valve one was about this high, full rack. And the new one we were making, the receiver was that high, and the transmitter was about that high. And so and they hadn't finished the design of it, so the engineer said, okay, we've got to make a modulator. That's FM, of course, VHF. Okay, how do we make a modulator? Normally, and I got my ALL handbook. I read that cover to cover when I was 14 and sat for the exam and passed the exam. Couldn't get the licence till you turned 15. That's stupid. Anyway, so I sort of, that's the Bible of all the stuff, that and Radiotron Designer's Handbook, which is a fantastic book. But of course, when this was written, whenever, in sort of the 1800s or whenever, it was, transistors hadn't been heard of, so it's all valves. But the depth that they go into of describing how to do things, the full theory, the whole works, those two books are fabulous. So, okay, how do you make an FM transmitter? Well, it's got to be very stable, so you've got to use a crystal. Okay, so the only way you can make FM with a crystal, you've got to pull the crystal. So you put a variable capacitor across it, a variable capacitance diode, and you pull it. And of course you've got to bias the diode with DC, and that means that if there's noise or any instability in the DC supply, it's going to drift around and all that sort of things. But I said, no, we are going to make a phase modulator. And a phase modulator is quite different. You think, what's the difference? Phase modulation and FM are virtually identical, except that in FM you're shifting the carrier frequency, in PM you're shifting the carrier phase. So with PM you can only shift it instantaneously. You can't, with FM you could shift it to there and leave it there. You can't do it with PM. So, but the other thing you do with FM, they use pre-emphasis. In other words, as the frequency, the audio frequency goes up, they boost it by 6 dB per octave. And then the receiver, they cut it down by 6 dB per octave, and that improves the signal-to-noise ratio. But PM does that automatically because it does rise 6 dB per octave. So we didn't have to pre-emphasize, just a minor trivia. So a phase circuit, either that or the variable capacitance diode off to the audio signal into the DC bias. So by varying the capacitance, you instantaneously vary the phase. The deviation you get is very small. So you've got to start off low, and so on this thing, I think we start off at 6 meg and multiplied up to 160. The two VHF bands was 80 meg, around about 80 megs. I forget exactly what the limits were. The 170 meg band was 148 to 174 megs. So we did make some 80 meg stuff, but PMG mostly used the higher VHF band. And so we started off at about 6 megs and multiplied it up, and that gave the bigger deviation. We also had 120 kilohertz channel spacing, cut the channel spacing down to 60 kilohertz. So we reduced the deviation by half, of course. The requirements were things like transmitter spurious had to be, I forget, probably sort of 60 or 80 dB below the channel interference of about 100 dB or so. So one for the 3825, so it only passed that to the detection section. So I had to design those modules, and hey, my trusty books had all the sort of how to do this, so I made all those up. And I worked out the inductance of the pot cores required, and they made those. And of course, they don't get them all exact number of turns and so on, so I had to then, for each filter, drive across it and with an audio generator and monitor it, and if necessary adjust the capacitors to get it right. Then once it was all finished, well, there's another thing that I was surprised at. They had a power. It was designed to run at 48 volts because most telephone exchanges, all telephone exchanges, had a 48 volt whopping big room, a battery room, sort of half the size of this, and that's the normal voltage on telephone lines. So it ran off 48 volts, but there was also a mains power supply, which is sort of that high. It had these whopping big filter capacitors on. I said to the chief engineer, I said, why are they so big? You can get the same capacitors and the same voltage in a much smaller capacitor. He said, I said, the reason is that what does a filter capacitor do? You know, you've got your rectifier there, you've typically got that, electrodes, so on. So the pulsating DC comes in here, you want clean DC coming out there. Now, so you've got effectively the signal coming in here is like that. So it's sort of a half polarity AC signal, and the capacitors have got to absorb that. And capacitors, especially electrolytics, have got some resistance. So that AC current that's going into the capacitor is going to make that resistance hot. And that's why they had these big capacitors, because they are rated for ripple current of a couple of amps, whereas the little teeny ones couldn't handle that. That's why we have these big capacitors. So, okay. All these sort of trivia things that I learned along the way, which is fascinating. And then we had to have the PMG engineer come in and do all the acceptance testing of the first one. That involved, it had to operate without any alteration, without going out of spec, from -10 to +55 degrees. So we had a fridge, a big, like a big shop fridge for the -10, and a big box with a fan heater in it for the 55, and we stick it in both and have the leads coming out and do all the tests, and we got it through, and then into manufacture, and PMG inspector would come along, and I had to individually do every single system. There were probably 100 or so, I forget now. Every single one had to be fully tested to all its specifications. So it took a couple of years to get through all this, the actual manufacture. Towards the end of the several years I was there at Walkham Hills, the company was bought by Philips, because Philips had the big electronics setup in South Australia and in Victoria, but they wanted to get into this professional market, so they bought our company. And so they started manufacturing these single channel links, and things like the filters, they'd come pre-aligned. They had, instead of fiddling with capacitors like I did, they had pot cores with a little tuning slug in, so they could actually adjust the inductors, and so they could just use 1% capacitor to churn all this stuff out. So the stuff would just come in. I'd put the rack, put it up on the unit, put it up the rack, and spring there, it all worked. So that saved us a lot of time. At the same time, Noel Miller was working on an ISB link, telephone service to these Northern Territory places. And ISB meant that two independent sidebands could have you two separate channels. And again, because the requirements were so tough, the engineers used mechanical filters. Mechanical filters are a fairly low frequency thing, so they're on 200 kilohertz. So we started off at 200 kilohertz, balance modulator through the two filters, and so the balance modulator for each through the two filters, and we combine the two. Trouble is that then these radios worked, I think, from about 6 to 15 meg, something like that. They had a turret, because day and night the propagation conditions are different. So it had to be able to rapidly change frequency. So it had a 4-position turret. It was about this big, and 4 positions. And so when the time came to change frequency, turn the motor on, clank, 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 and it switched to the new thing. Had a couple of 4CX 150s, no, 4CX 350s as the valves, and produced I think about 500 watts or so PEP. And Noel was working on the receivers for this, and because it started off at 200 kilohertz, I could hear him on his bench over there, sort of muttering to himself, this thing's got more birdies than Taronga Park Zoo, because of all the mixers and different things. And he finally figured out that it was the 200 kilohertz. So getting a birdie every 200 kilohertz, he finally figured out it was the 200 kilohertz sneaking down the supply lines. Only a little bit, because remember we sort of had 100 dB down. So simple enough. We just put a parallel tuned circuit in series with the power lines to the various modules and so on. It was made in little tin cans, a whole series of little tin cans all put together, which gave shielding to the various subsections of the system. It was made on Vero board. There's only 4 of these transmitters made, so, and printed circuits didn't exist anyway. For the VHF stuff I was working on, it was either mounted on little ceramic pillars with a little solder lug on top, or fibre boards. Now, the normal fibre that you would see on tag strips and so on, you know, the tag strips you used to have, which is like a strip with a little thing sticking up, really crummy inferior stuff. So they used some sort of fiberglass material that was white, and they mounted little posts on it called turret lugs. So it's a dual olive hole, they put the lug in, and this sort of thing that spun around and turned the bottom of the lug over, and so had those little turrets all along the boards, and you string the resistors and capacitors across those. But because it was a high quality board, it could stand the 95% and humidity and temperature requirements that this sort of stuff had to do. the little tin cans had a brace with pins on made of ceramic. Don't know where they got them from. The little handheld units, each stage of the transmitter and receiver was in little tin cans about an inch square and about half an inch thick. So there'd be one stage of a transistor and little ferrite coils and different stuff in there. They use little ferrite beads with wire through for the inductors because it's effectively a toroid, so it's got a very small exterior field, and so therefore it's not affected too much by the sides of the little can very close to it. The guy that was working, I would have loved to have worked on those handheld things. The guy who did those had a bit of an accent, and I asked him one day, you know, I'm a silly young kid, and I said, accent, where are you from? He said, Indonesia. That any people from Indonesia were in Australia. This, you know, the White Australia policy kept them all out. But I was just astounded that he was this technician from Indonesia doing all this sort of work. I don't mean that Indonesians weren't. I'm not saying that Indonesians are inferior or anything like that. It's just that I'd never come across somebody from Indonesia in Australia. You get from Europe, yes, but not from Asia. So that was all these funny things that I'd come across all the time, which I just learnt so much. I just amazed at the life I've had of all these things that happened. Anyway, so I had to do the acceptance testing for these HF stuff as well. We got all them done. And Phillips just had a big complex at Brookvale, and the house at Balkan Hills was far too small, and it wasn't an industrial area anyway, so the council wasn't really happy about having it there. And Phillips had this huge complex in Chard Road in Brookvale. They had the factory there that made lights, and they had another factory, I don't know what it's used for before. So they said, right, shifting you to Brookvale. I'm away from home. I lived in Irvington, which is just down the road from there. But at any rate, that was around about the time of conscription. Now, of course, you know, conscription, they just run a ballot. And the numbers that come out, oh yeah, such and such a birthday, right, we're taking those people. All above board, very fair and straightforward. Ha ha ha.
Except it was on 17-year-olds and you couldn't vote.
Well, exactly. And so, and of course, they would have sort of gone through the list of the creative register, and of course, they would have looked at me working on all this special equipment. Oh, we don't want him, do we? So I got called up, did the medical, 100% fit. Okay, and supposedly, and the anyway, the factory they were in the process of moving to Brookvale. I didn't want to go over there because I was due to show up at Kapuka in a few weeks' time, so I just stopped and had a bit of a holiday, and I got very ill. I didn't know, but I'd lost a tremendous amount of weight. I was starving hungry all the time. I was urinating gallons and gallons of liquid, thirsty all the time. And eventually, I know one day, my mother had made this cake for a friend of mine. Made this cake. I said to a friend, "Do you want some?" No. So I ate the entire cake. Then we went into town to the movies, and there was this big chocolate honey roll. So I ate all of it. And I was still hungry. And my friend said to me, "You thought maybe there's something wrong with you?" And me. So I went to the doctor. He said, "You know what you got, do you?" I said, "No." He said, "You got diabetes." "What's that?" never heard of it. Yep. I said, okay, right, well, so what do we do? Give me some pills? No, in hospital, straight away. Can't even sort of tell my girlfriend I'm going, no, right this minute. So I spent a week in hospital, something like that. So I'm sure I would have had symptoms in the Army Medical. But I suspect that they are. Right. So of course, I was no longer medically fit. Now, I know it sounds like a conspiracy theory, but a friend of mine who's been in the military all his life, he was head of the survey corps, and he had a year in Vietnam. Now, in Vietnam, because of so high humidity, they printed. So when they were going to do the soldiers were going to do something or other, first thing they need is maps. They printed them on silk because that's the only thing that could survive the high humidity and the temperature. There's only one company that did in Australia, and they had 2 technicians. So, funnily enough, one of their technicians got called up, and when he'd finished his tour, the other one got called up. What a strange coincidence. Funny about that. I was talking about this to I fix model trains and that now. Talking to a barrister who brought some trains, and he said, he's talking to Normie Rowe, because Normie Rowe, of course, got called up, and Normie was talking to a friend of his afterwards, and his friend had the same birthday date. How come I got called up and you didn't? Everybody on that birthday date should have been called up, and so he said, there's something wrong here. And so he actually got onto the department eventually, because he's an important person, he's got enough pressure, and found out that the department that did it all said, well, the US Army have Elvis, which was a good publicity thing, so we'll get somebody. So Normie Rowe, we'll grab him. So they did. So whether this is my naive conspiracy theory or not, I don't know, but anyway, that's what happened. So I didn't want to go to Brookvale, so I went to the Warmels brothers. So I was at home with my parents in Ermington. I had to get used to dealing with diabetes and allow me giving myself injections, and we've got all these gadgets now. So I can read what my blood sugar level was. We couldn't before. So I got a job at Warmels Electronics at Silverwater, and that was funny. I was in the design department, and first thing they said, we want a bell, because bells, the alarm bells have got the way a bell or a buzzer works normally has got a contact which is closed, and it puts current through a solenoid which drives the donger, but also opens the contact. So it then licks back, and so it goes dong 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 dong. Fine. They wanted one that didn't have contacts, because these bells are normally mounted on the outside of the building. Weather come up with a contactless bell. Oh, okay. And I had the GE SCR manual. I don't know if people still use SCRs these days, but they did then. And it showed a flip-flop using 2 SCRs. That's just what I need. So I got the people to wind up a coil and made up this SCR flip-flop. Now and there's a steel rod in the middle, which just went dong 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 dong, and boy was it loud. It was ear splitting. And they said, oh great, exactly what we need. But they never ever made it, unfortunately. So one of the technicians working for me used to have difficulty waking up in the morning. He knew it was late. So he took it home, connected it to his alarm clock. He said, from then on he was on time. Anyway, I was there, but all these sort of funny things, fire things and alarm things, I want radio. So after a year there, I was getting married, so okay, we'll move to Brookvale because my wife wanted to get away from my mother, naturally enough. Funny about that. My mother was a very controlling, interfering person, so she was quite justified me. So I said, okay, move to Brookvale, and I went back to Commonwealth Electronics, and it had grown a lot. So we started on the next range of these single channel links. This time they're that high instead of that high, and had little plug-in modules. Each was a sort of a box, and it would have something like the IF stage, or the tuner, or the driver for the transmitter, or the audio. One thing I didn't mention with all these systems, because telephone lines are 2 wires duplex, and a radio system isn't. So you've got to have the 2 wires come in, you've got to split it into 4, but you want the spec, we always exceeded it. So our 10 watt units would typically make 12 to 15. You said, oh, everybody else's, if it was a 10 watt unit, would be lucky to get 5. But the other thing was the fact that it came straight up, that's where my missing test crystals were. Okay, right. Anyway, the RF printed circuits were double, like 2-sided. They had a ground plane at the top and the things underneath. We had plated through holes where we needed to join something to the top. Printed circuit boards, at least then, I don't know how they do it now, they were made by etching the top and the bottom and drilling the holes, and then they'd squirt some sort of conductive stuff in the holes and plate it. It didn't always work, and so we had on I'm assuming you guys all know what a TF5 can is, with transistors. So we had the TF5 can, and then we had the ground plane along here, and we had a Teflon, very thin Teflon washer, and of course the transistor, the anode, the collector was the case. So the case, that's why the insulating washer. And then the tracks are underneath, and so the emitter had to come down to the bottom. And it was supposed to be a plated through hole. The reason being is that if you have a transistor with an unbypassed impedance in the emitter, you reduce the gain. And another bit of trivia is that, in fact, if you got that audio, the gain is that divided by that. But anyway, so some of these driver units were low on power, couldn't get the half watt, couldn't understand it, so I finally pulled the transistor out and realised that the plated through hole wasn't effective. And so therefore we had a 16th of an inch of emitter. Yeah, that's not much, but it's an inductance. At 160 megs, that's a significant inductance. And so it reducing the gain of the stage by that much. So we solved that by putting a rivet, solving a rivet to the ground plane at the top through, so that we always had the contact. It was filled with solder when it was soldered, so it always has contact emitter right up there, not down there. So all these sort of funny little things that we come across that were weird. We started off using Phillips resistors, they're sort of at that 1.5 watt version. They're actually a ceramic body and spluttered carbon deposit on them, and then they cut it, a spiral on it, to make the resistor value. But of course, you made an inductor. And so Phillips resistors are very good inductors at UHF and so on. Fortunately, metal film resistors came out then, and they weren't made like that. They actually cut away the thickness of the metal film with a laser to get the resistance. So we started using those, which solved some of the problems. Another thing with the receivers, they tended to be a bit unstable. We had bypass capacitors. You think like the normal sort of bypass capacitor used at RFE 0.11, the little blue ceramic ones. They're ceramic. They should be good. But in fact, a capacitor. You see, a capacitor, if you do a chart of impedance that way, Z, and frequency, as a frequency, capacitors are self-resonant at a particular frequency. So that's a series circuit. Once you get to the self-resonant frequency, then they become inductive, so they're no longer effective. And we found that in fact that the most effective capacitor to use on our UHF units was a 0.01. 0.001. I think I put 001. They were self-resonant well above 500 megs for our UHF ones, but the 0.01s and the 0.1s were, the 0.1s I think were self-resonant about 100 megs or something, the 0.01s a couple hundred megs. So there was all sorts of weird things we found like that. And in addition, so we've made a few hundred of these VHF units. That was great fun. Then they say, okay, we've done the 160 meg ones and the 80 meg ones. Now we're going to do a 470 meg one. So this is in the late 1960s. UHF transmitter transistors just didn't exist. How are we going to make a 470 meg transmitter? My father used to, he was a chemical engineer, he used to get the proceedings of the IRE, Institute of Radio Engineers, for some reason. I don't know what, but he'd bring them home, and I all sorts of fabulous things in those. And one of them was a power variable capacitance diode, one in something or other, and so it was a big diode, so it was stud mounted, and this person was saying, hey, for 500 megs you can produce, you can use it as a tripler. And so you start off with a VHF and multiply it by 3 times, and it's very efficient, these new diodes. And so I thought, okay, can we get one of these diodes? Oh, no, but Philips make a BAY96, the one that was specified I think was rated 10 watts. The BAY96 was rated 20 watts. So yippee! So I made up the circuit and shoved our 15 watts out of the 160 meg unit into that. I got 12 watts at UHF. Hooray! Easy. But of course it was horribly unclean, because multipliers don't just multiply by 3, but they also got things either side, 2s and 4s and so on. So there's always other horrible harmonics. And how are we going to get rid of that? I saw in QST there was some guy had made this a little box. I draw it bigger than side. Little box. This is just from a side view. He had a hole in the middle, and he had I think he put a tap in there and a tap in there. It was a helical filter. and by adjusting the size of the hole between the two, you could adjust how much coupling to get it to the right amount. So, and because of course it was meant for the 432 band, it was fairly narrow. So we said, right, we'll put a screw in there, in and out, and that'll alter the tuning. So I got the model makers to make that up, and they said, hey, okay, well, we haven't got any brass rod that will... I said, get some brass rod, thin brass rod, and make it up. Haven't got any brass rod. And that's when I said, welding rod, brazing rod, which is brass or brass compound. They made it out of that because you can bend that. And since it was going to be silver plated, it didn't matter what it was anyway. So they made that up. They put for additional stability, they put a Teflon, the PMG, to do the spectrum analyzer tests because we didn't have one. We had a sideband analyzer, which is narrowband. We didn't have a broad spectrum analyzer, and so because again we had to certify that the harmonics of the transmitter are 100 dB down. They said no. He said, but we measured this filter. The filter is good, and eventually, because so we had all the modules lined up like this, and the filter was in the back of the case, and each module had little coax TNC connectors, not BNC, but TNC because they're threaded. The cable went RG58 went round to the filter and then out to the type N connector on the back. What we didn't realise, because the coax is coax, keeps it in, doesn't it? But RG58 doesn't, because it's a braid, and so some sneaks out between the braids. And so somebody came up with the idea, we'll use double shielded coax, and that's what the problem was. It was just leakage from this cable between the transmitter output and the filter, sneaking around the filter and onto the output. So all these sort of weird things like that. Another thing we made was a 1 kilowatt linear. We also made a VHF linear because we had, for the aircraft band, 108 megs or so, we had receivers and transmitters. They were designed before I started there, so they're pretty primitive, but they also they worked. Only 3 watts output, but the RAF bought some, and Civil Aviation bought some, and so on. And where they wanted bigger power, we had a linear, and on that AM as well. They were AM, of course, because the aircraft band is AM, isn't it? So we had to boost this 3 watts AM up to 100 watts. So that's pretty hefty linear that can do that and pass it through without any problem. But so there's a couple of 4.6 150s in a metal box, so on, bobbing big power supply. So the whole thing was this by this and about this high. And there was one weird thing there. We had to certify that the power factor of the power supply was in certain limits. Power factor, what's that? Well, power factor is how far from resistive the load is. So things like fluorescent lights are capacitive. No, they're inductive because of the ballast. So that's why they put correction capacitors in fluorescent lights to balance out the power factor. Because if you have too many fluorescent lights all in a row, then the power factor gets messed up. And what happens is that because the current being drawn is out of phase with the voltage, you cheat. Because the power meters on the switchboard then were a mechanical device, and they couldn't tell. They measured current, so they read low with this, and that's why you're required to do this. So for some reason, we had to measure the power factor of these power supplies, and we had other tests as well. I had to use a mega to show that it was minimum 1 mega ohm resistance, insulation resistance to ground, all this sort of stuff. But I love those. I can't remember the name. We also had this 1 kilowatt HF linear. Loved those. It was a 4CX1000. Kilowatt PEP, and it was driven by 100 milliwatts. It's just a linear. Okay, how do you get 100 milliwatts at RF? So I just got 2 crystals, same, and I pulled one sort of a couple hundred hertz away from the other. So effectively I had 2 RF generators, slightly different in audio, in terms of audio, I think, and joined them all together, and that was the driver, and so on. How do you measure a kilowatt of sideband? The only way we knew of was we had a true RMS meter, RF voltmeter, made by Philips years ago. So I knew, a 75 ohm load was all resistors in series parallel, so we shove it into that and measure the voltage. Now, Ron Hope, the founder, he was busy at one stage. The Navy had these 10 kilowatt transmitters with incredibly ancient, and they wanted them upgraded. And Ron said, you know, they made them in 1850 or whatever. So, let's build new ones. So he had to make this 10 kilowatt linear. Okay. And how do you measure 10 kilowatts? Same way. He had a water-cooled resistive load, so it measured the voltage on it. And while it was still running, he pulled the voltmeter off, and the arc followed it and melted the head of the thing, because they hadn't made these things for decades. So it was the only one we had. How are we going to measure this? But fortunately, we contacted Philips, and they looked to all their branches worldwide and found a replacement head. Oh, thank goodness. So because there was no other way we could, well, with the 10 kilowatt transmitter, they then just measured the temperature difference between the water going in and the water going out of the, and they knew the flow rate through the load, so they could measure the power that way. And that was funny. He was sort of off in the corner. One of the technicians that worked for me, I said, you can work with that. And he said, hey. So, okay, righto. So I did some of it, and Noel Miller, who had been in Papua New Guinea for a couple of years working for Philips there, came back and he did it, and so on. But anyway, these 1 kilowatt transmitters, they were fantastic. It was driven by a 6146, which is in turn was driven by a 12BY7 to get the whole 1 kilowatt thing. And the ceramic tube is a high gain thing, so it didn't need much gain behind it. They ran at 2.5 kV on the anode for 3-phase. For AM linear operation, we had to bump that up to 3 kV, so we had to change the taps on the transformer. This, of course, was a case of, and doors you open, and had stop switches on the doors, so the 2.5 kilovolts in there, you don't want people being able to poke around inside. But of course you could stop that, and of course we did, to work on them. And there was a big hook on the door, on a sort of a heavy wire rope, which you, if you opened up the doors with it on, or even if it had been on and turned off, you put that on the big coil just to make sure that the power supply capacitor was fully discharged. So when the power was turned on, it would wait 3 minutes before it turned the HT on. Just little things like that. So how are we going for time?
It's been, and look, you've been going for an hour, which is an achievement, so maybe you should just wind it down.
Okay, well, I've only touched on a few years of what it was. It's just, I just had the most wonderful time. I loved it. You just can't believe the astonishing gear that I've only mentioned a fraction of it. It was all way in front of what anybody else was doing, even AWA, because we had the flexibility as a smaller place to do this. Technicians come over and we trained him on what to do and so on. One of the linears, the 1 kilowatt unit linears, CFA, Country Fire Authority in Victoria, bought one, and so their radio guy came up. He had all these questions, so I ran him through it and I told him all the lurks and all the different things. He was actually tickled pink. He, as a hobby, beer bottles then were that long. Stubbies didn't exist. He used to cut the tops off them and put a handle on and make mugs. He brought one up for the boss of the place and he said, I'm not going to give it to him, I'll give it to you, Norm, because you've helped me out. So I've still got that. It's a souvenir at home. So, yeah, I'll shut up. I'll have to come again because I've only touched on a fraction of it. There's the military radio gear I worked on and so on and so on. So some other time if you want me, I'll come back and...
So Norm, we all want one of the 1 kilowatt linears. Have you got any left? 10. Yeah, we want lots.
Well, in fact, at TAFE, no, so the final job I had was TAFE.